Alright, so you guys are the first class that I'm going to try this on, so don't make fun of me. Good morning, my lovelies. I have to say that because I know you'll miss it. So, algebra for calculus. Today we're going to go over interval notation. Domain and range. Of a function. And possibly graph piecewise functions. I just now noticed it wasn't real clear. Sorry. Is that better, hopefully? Good thing we hadn't gotten started much. And by the way, I'm going to have to constantly erase, so don't make fun of me. Well, you can make fun of me if you want, because it won't hurt my feelings, because I'm not there. So first of all, interval notation. Standard. That's what you used in junior high, in Algebra 1, and most of the time in Algebra 2. I hadn't ever used, or at least I didn't remember using interval notation when I was young or even in college. Not until probably 10 years ago do I ever remember interval or being introduced to interval notation. But I am a fan. I'm a big fan, and it's also extremely useful when you are going to solve polynomial or rational inequalities, because you get chunks of a number line that is true for those as your solutions, and they drop right. Interval notation drops straight down from a number line. So just let's think about what we would write in standard notation. You might say x is greater than 5, and if you picture that on a number line, you would have drawn an open circle with an arrow going back toward the right in the greater than direction. My junior high boys I used to teach wrote so fine and light I could see the open circle, but I couldn't see which direction the arrow was going. With interval notation, instead, you use a parenthesis, and the parenthesis actually points the direction you're going, and so then it's not quite as important to go like that. And also, some of the one textbook, just only one I've seen, has infinity and negative infinity at the end of the number lines, just to remind you. And you can see now that this notation is taken straight down from the number line. So when my students struggle with this, it's usually because they are not graphing it in the first place. Now, it's an open circle because you can't touch this. It's a parenthesis because you can't touch this. So in other words, a greater than sign is replaced with a parenthesis that opens to the right and to the greater direction. Again, negative infinity and positive infinity can never be reached, so they will always, always, always be parentheses. But let's say you had x is less than or equal to 7. In standard notation, it would be a filled in circle at 7 going in the less than direction. In interval notation, it's a bracket, and it points the direction you're going. And just like I said on the last one, it literally drops straight down from the number line. So on this one, we'd have negative infinity to 5, 7. There's eraser number 1. And the bracket means you can touch this. If you were graphing, say, x equals 5, let's say negative 5 or 2. In standard notation, that would just be a dot at negative 5 and a dot at 2. No chunk of a number line. Only inequalities give you chunks of a number line. And this would be how you'd write it. In interval notation, we would use something called a roster. And a roster is where you list elements separately. So you just list them. That means individual numbers are your solution. If I'm going to list my class, I would list each one of you separated by a comma. So that's a roster. Sometimes you've got maybe x is less than -1 or x is greater than or equal to 3. Again, I don't waste my time putting units on this and labeling them. All I need to know is comparison to one another, that you know that the -1 is to the left of the +3. And if I had to graph this in standard notation, that would be an open circle going to the less than direction and a closed circle going to the greater than direction. And you can see that the arrows I'm drawing are a little harder to see. In interval notation, doing the same thing, -1 and 3, the parentheses point the direction they're going. So even if my line and arrow doesn't show up, I know this one's going toward -infinity and this one +infinity. Now to write that in interval notation, it drops straight down. All these numbers, when you're writing in interval notation, are always from smallest to largest. So you would never write an infinity, 4, because 4 is smaller than infinity. The smallest number is always listed first from left to right, and then they get bigger. So this is going from -infinity to -1. It's not allowed to touch 1, and then it's in union with 3, and it can touch 3, to +infinity. So, interval notation, you'll like it. The book also touches on set builder notation. These are kind of like set builder notation, but set builder is a little bit pickier. Set builder notation, okay, I'll be honest, I hate it. My best friend loved it, but I hated it. If we're doing this one right here, x is less than or equal to 7, we would have to say the solution is an x such that x is less than or equal to 7. That really stinks. That you write that it's an x that we're looking for. If it was an ordered pair, you'd put like a parenthesis x comma y there, and you'd say maybe x is a member of the even numbers and y is negative, whatever. It doesn't matter, but there's different ways to use set builder notation, and I'm never, ever, ever, ever going to make you write something in set builder notation, so enough of that. All right, domain of functions. So what we talked about the other day was what exactly is a function. A function assigns to every one x, there's exactly one y, only one y. To my one fingerprint, it will only point to one person, me. That's a function. If I get paid by the piece for items I produce, and I get paid $10 no matter what for an item, then making 3 items will give me 30, but making 3 items wouldn't ever give me 40 if I'm following the same function rule. So functions don't necessarily work forward and backwards. When you turn them around, it's not necessarily the case, but we'll talk more about that after I'm back. The domain of a function, in a nutshell, is the input. It's what you put into the function machine. Think of a function as a machine that's doing something to the input. The range is the output of the machine. Okay? So for some functions, the domain is basically what is allowed to be in a function. The numbers allowed, Didn't spell that right at all. To go into a function.